How can the Pipeline Pro system be adapted to any type of project? Well, almost all system customization settings will be located within the Pipeline section. This section can be found in several areas, primarily naming convention, technical specifications, and the rest of the systems available in the top menu. In naming convention, we can define the project initials, the main folders where material will be stored, the local landing folder on the server, and the project name within the directory structure. As you can see, this is where we define the naming convention. Here we also define what is called local and cloud storage. These are folders that, in addition to the 4 main working directories of the system, can be fully customized and accessed. These folders can be used through the storage system to upload material and store it in the cloud so that it can be used across all pipeline structures. For example, if we have a specific DCC version that needs to be deployed, such as a custom version of Blender used in production, we can store that version in the cloud and call it through code lines to deploy it when needed. This is one practical use of this system. In addition, we have the full set of variables used at the project level. Many of them reflect configurations from other sections, while others are custom variables that the TD can define to store additional information. We also have a summary of the naming convention that will be constructed within the scene for both assets and shots, as well as specific operational variables such as automatic assignment systems, permissions, or whether underscores will be used when building the naming convention. This allows us to determine whether asset names should include separators or not, and to automatically remove them when generating names. For shots, we build the structure based on 3 levels: episode, sequence, and shot, with the possibility of adding layers when working with multi-layer shots, for example, in compositing workflows. In the Publishers section, we also define a 3-level folder structure to store working files, published files, review files, and working in progress files. Creating project variables allows us to define new variables with new values. This means we can create a specific variable for a project that needs to be used through the API. Later, we will see examples where this can be used to build systems such as MISH version validation or plugin installation within a DCC. In TechSpec, we define the technical specifications of the project. Here, we set parameters such as resolution, number of episodes, FPS, color space, the list of DCCs and their versions for validation, and third-party integrations. For example, this could include integration with the Slack group or ShotGrid. If the system is configured and we want to assign a project number to synchronize both platforms, we can do so. We can also define how we want to work in Harmony and Nuke, along with other DCC-related variables. We can also define camera lists if needed, automatic publishing elements, automatic status changes, whether shot headers will be used, which is very important in VFX, and the starting frame we will use, frame 0, frame 1, or frame 1001, depending on project requirements. Similarly, we can define the list of resolutions used in DCCs, the resolution used for reviews, whether headers, override, overslate will be used, and the delivery formats required by the client, allowing the system to understand the technical commitments established for the project. In the Departments section, we configure where each task is stored. For example, in modeling, we define which tasks belong to the modeling department, which folder they will work in, what suffix will be added at the end of the name, and which DCC will be used for that department. Likewise, in asset types, we define task progression and average durations, which helps production management track performance and evolution. Validation systems define progression states. We also determine the main working state, which helps calculate working time and identify the current status of each task. This percentage is used to improve accuracy when calculating the overall completion percentage of the project. The dependency map allows us to define relationships between tasks, which is especially useful for chain downloads, particularly for remote workers. In DCC tools, we store all execution code developed by the TD. Once configured here, it allows us, for example in Maya, to generate new tools or menus containing code directly inside an element. For instance, we could create a button that refreshes all dependencies, something that does not exist by default in Maya. This allows users to refresh dependencies without closing and reopening the scene. These are additional functionalities added to the workflow. These features operate at the DCC level, and we can also load specific tools depending on the task type. For example, if a task belongs to the modeling department, we can load additional tools that are only necessary for modeling. Here, we can also define pipeline behaviors for the project. For example, what happens when a new task is created, what happens when a scene is opened, which checkers will run inside the scene, and what happens when publishing, whether it is a WIP, a review, or a final publish. We can also include code for automatic conversion to formats such as USD, FBX, or any other format required during the publishing process. This allows us to integrate nearly everything needed within the pipeline. In addition, we have a pipeline library where TDs can upload libraries that will be provisioned to the client and invoked from Python code within the code editor. With this system, we can load those files and execute functions required at a general level, and the system will automatically deploy them wherever needed. This provides full customization of system behavior. If we want to integrate the pipeline with other systems, we have a webhooks section that allows us to create endpoints to receive information from third-party programs or send requests to external systems. We also have a custom attribute system. These attributes defined in the pipeline configuration are available across all entities. This allows us to determine which entity will contain a general attribute. For example, we may define a camera model attribute for shots. This attribute is accessible from both the web interface and the API, allowing us to store additional information in the database for that specific project. In this way, we can create complete variable sets for all shots. However, if we move to a specific shot, in addition to the general information shared by all shots, we can define a unique attribute only for that particular shot. This attribute would appear as a dataset specific to that shot, enabling specialized integrations when required.